Hello and welcome to Checking the Vitals, a podcast powered by SpecialtyCare. I'm Todd Schlosser, and today our guest is Dr. Zain Khalpey, the Chief of Cardiothoracic Surgery at Northwestern Medical Center. In this conversation, we discuss why he gave up being a pilot to pursue medicine after his family experienced a medical emergency, how he developed ways of remodeling a damaged heart, and how he is using artificial intelligence to find new ways of preventing someone from having a heart attack. Enjoy the conversation. So, Zain, thank you so much for joining us today. And I'd like to start out asking sort of a similar question every time, and that is, what was it that drew you to want to dedicate your life to healthcare?
I think the old adage of wanting to help people is fairly boring. I think, sorry, but it's true, but it's how you help people that counts. And I think that what appealed to me with cardiac surgery was the fact that you get results quicker. And I felt that I, um, so my father had a stroke,
Oh, wow.
just like your father,
Yeah.
and he had atrial fibrillation, and he also had lung cancer. And I thought to myself that even though I wanted to be a pilot, I was really drawn to technology and trying to see how I could fly in different ways. So I thought maybe I could use technology to help facilitate some of the cool gadgetry I was in love with. And what subspecialty in medicine that did that for me with quick results, and not binary results, but very nuanced results, and to work as a team in a tribe of people who love doing what they do, and that is coming full circle to your answer, caring about patients.
Sure.
Uh, and I thought we could do that. In that way, and that's what drew me to being a heart surgeon, because I could also have a lab that would allow me to innovate, and it was not just the operating room where you could do some really meticulous but beautiful stuff, but you would be able to help people and translate that out of the operating room using technology. And so I thought that it was a very um, important thing for me to feel that I was making a difference to not just somebody's life, but their family and maybe the community.
So, do you think it was that sort of pivotal moment with your father that sort of drove you into want to get into healthcare? And then once you got into, let's say, the beginning stages of learning about, being a doctor, in your case, surgery, was that when you sort of opened it up and thought, well, I could actually help not just the patient, but people in general? Or was it always, I want to help people in general? And you knew that to be able to get to the people in general, you had to focus on the patient and that one person, because you have to understand how to help one person before you can help many people. So how did that thought
Yeah,
process come about for you?
yeah, no, that's a really cool question. And I haven't
Why,
thought
thank
about it
you.
this way. So, yeah, and I thought that with some something individually happening to you and your family or your nuclear family on the medical side of things, just like how COVID is happening now,
Yeah.
it affects you very deeply, very personally, which almost scars the mind.
Yeah.
But people can either be scarred by it and fester and become just a lump of jelly, or you can actually take action and do something. And you can find a creative way to do something even more. But you have to have that anchor, and that anchor for me was my dad. And the fact that I couldn't do anything about atrial fibrillation, his stroke, and I felt helpless
Yeah.
to the point where it kind of gave me a shot in the arm to say, you know what, I'm not going to let this happen to any of my patients. So, for example, right now I clip every one of my patients um, uh, and use criteria from something called the Atlas trial on every single patient I have an open chest with, and they will not have to worry about them getting a stroke because I've reduced that chance by 70%. So, yes, that one episode has affected the rest of what I do in my career, but also um, in order to expand on that, how can I change that to looking after millions of patients or affecting millions of lives? Uh, and that would mean using technology to either predict people who, before they come to having heart surgery, what their risk is, but can I also predict them going into AF? So we have FDA approved modules, the first ones in the US, by the way, in our hospital that actually predict people and have the FDA approved algorithms to predicting AF and how we can prevent them. So going full circle to answering your question, yes, there was one patient that affected my life. It was my dad, who wasn't my patient, but even when the nurses poked him to get blood millions of times from him, which he hated,
Yeah.
I ended up doing it myself because I knew he would feel less pain if I was doing it myself instead of somebody else who couldn't do it effectively. And I was a house officer at that point in the United Kingdom, in London and Cambridge. And,
Can you briefly describe what a house officer is?
oh, an intern, yeah.
Oh, okay. So was this while were you interning while you were at the School of Medicine, at the London School of Medicine, or was this later or before that?
So I went to medical school because of what happened to my dad
Sure.
first time, and
Oh,
then
okay.
when I was in medical school, decided to become a heart surgeon after I first watched my first heart operation, and I thought, bloody hell, if I could come in every day and look at that, that would be amazing.
That takes a special kind of person, I'll be honest with you.
Yeah, I mean, to see the heart beating is a unusual thing, and just to see that affects somebody's life and how you stop it and then reanimate it is mind-boggling. So yeah, no, that's exactly why. And then when I was in medical school, um, I learned how to take blood when I was there because in the UK it's a different kind of philosophy and a different flavor about how you grow up in medicine as opposed to in the US. But then when I came here and had to get retrained at Harvard at the Brigham, it was cool because I really appreciated the Americans and their training in surgery, and it was much better than the British and training, and I felt I became a much better tooled surgeon, a much rounder thinker, rather than waiting for an attending or a consultant to die before you become a heart surgeon. America had it right, and they had a pathway to not only allow me to innovate, but allow me to be who I wanted to be and add my flavor into how I could be different as a heart surgeon. And that's kind of what it was exciting about coming to the US to do my research and my PhD, because thinking about it when I was at the Mayo Clinic and at MGH in Boston, their thinking was really um, cutting edge, and it allowed me to fantasize more about what was possible rather than impossible. And then it later on allowed me to kind of make the impossible possible because
Sure.
I felt I had learned new tools and I had new tricks. And that was the beauty of coming to America, where it was also a meritocracy, and people treated you for who and what you brought to the table, as opposed to what your genotype was.
Sure.
So I felt it was refreshing coming to the US.
A lot of people that we talk to, especially in your space, the cardiothoracic space, they focus on, hearts, maybe even heart and lung transplants. But you focused on the cardiothoracic space, but also bioengineerics. And I wondered, what was the draw for bioengineerics? Is that something that most people go through, or most, I should say, cardiac specialists go through, or is that something that you sort of sought out as sort of a unique career path for you?
So I think it's about bioenergetics.
Bioener
Um, what I was,
Bioenergetics. Okay, sorry. Yeah.
yeah. So it's immunobiochemistry. If you break it down, and I was fascinated by transplant, and I was fascinated by how the heart worked because it beats 100,000 times a day,
Yeah.
and it never runs out of bloody energy. So I was fascinated by the tool which powers that, and that the cell, it was the mitochondria. So I thought, how could we outsmart um, kind of bioengineered organs to circumvent the organ shortage for people? And so I thought maybe we could look at the mismatches of um, mammalian hearts and see if we could put a pig heart into baboon. And that was part of my PhD at the Mayo Clinic. And that's where bioenergetics came into it, as to could we not just immunology, but could we look at how the metabolomics and the metabolic issues are. It's not so gene therapy is really far off. Proteomics is the proteins involved from genes, but metabolics happens second to second. And that was really fast. And so the metabolomic story for me was more exciting because I thought I could outsmart the pathways, and it opened it up to pharmacotherapy, but also it was faster paced like cardiac surgery. And so I thought, let's see if we can apply this to organs, specifically the heart and the lung, and see if we can outsmart that in transplantation. So that's where I got into it. And then I realized that the complex of biology was beautiful, but technology was far superior in trying to augment the beauty of biology. And that's when I fell in love with the total artificial heart and wanted to see how I could use hybrid therapy, such as a mechanical device to offload a heart, but use regenerative medicine, which I'm bordered in, to allow you to think out of the box to keep your own heart instead of getting a transplanted heart, and using hybrid therapy to do that.
So when you say hybrid therapy, I assume you mean sort of organic and sort of technology coming together to enhance someone's cardiac function. Is that sort of what you're getting at here?
Yeah. Yeah. So I think you need to have two ways to think about this. One is, yep, you got to think of a biology of a perfect heart, then it getting damaged, then
Yeah.
how can you prepare it? When it gets damaged, say with a heart attack, it gets scarred. So how can you remodel that scar? So I started using amniotic membrane on top of people's hearts,
Okay.
and I'm the first one to do so in the world. What we saw was it was remodeling the hearts without the stem cells. And the stem cells have been a panacea. They haven't really increased muscle mass. So everybody working on it for the depth of it have been working in the wrong direction, which is why we don't have a really stem cell therapy FDA approved trial, because nothing really worked. And so one has to question that again very deeply and think about it in a different way. How can we use the extracellular matrix or an inflammatory story to remodel the heart? And were we missing something? And how can then we use technology to help recover that heart? So I was doing some of this on patients who have left ventricular assist devices,
Hmm.
which is safe, which means that the heart has failed but secure because they have a mechanical device.
Right.
And also patients who are having heart surgery every day, they can get an impeller or a device that you could place, which is a small jet engine in the heart, recover the heart acutely. But for the long-term scarring, could you use laser or injectable biomaterials, which are not cellular, to remodel the scar? And the answer is yes. And that's what we've got coming out fairly shortly in some of the journals. So we are showing that, we are doing that. And you've got to use technology to define new metrics. Metrics in terms of, can you predict the failure? Yes. Can you now show that we've got recovery? Yes. And we've got a Nature Scientific Reports paper coming out that will actually show that with the waveforms and the technology. And we've applied artificial intelligence in that to then develop the next phase, which is the predictive recovery.
Obviously, if someone has a healthy heart, they're not going to come see you. Someone has a heart attack and they have damage to their heart, they're going to come see you. And you guys have developed a technique to help, for lack of a better term, and correct me if I'm wrong, but regenerate the damage done to the heart during a heart attack.
Let's use the word remodel.
Remodel. Okay.
Regeneration is too much of an inflammatory. Yeah.
Sure, sure, sure. And that's why I asked you to kind of reiterate what I'm saying or sort of correct me if I go too far, because you've done the research. I'm just hearing about it for the first time.
Just to go back, just to let you know that if you are doing anybody who's normal, who's not going to come and see me, those are the kind of patients we need to focus on, because that's the risk factor profile that needs to be monitored. And that's why we have our artificially driven apps, artificial augmented intelligence apps, which allow us to monitor in a de identified way, HIPAA compliant,
Sure.
to make sure that we secure the privacy of our patients, but also do and use the technology, which is what my artificial intelligence lab is doing,
Right.
working with Google and Intel.
Not only do you have the ability to, as you say, remodel the heart, the damage that's done to someone who's unfortunately had a heart attack or had some sort of event, right? You can also, or you're working on, being able to identify someone who is, say, in a week or in a month, going to have an event. So you're working on not only the technology to repair a heart that is damaged, but also to get to someone before that damage is done. Is that what you're saying through that data lab that you
Yeah,
have?
and
That's
yeah, for
amazing.
example, we've got a clinical trial just starting up now where we've got this app linked with biomedical devices which monitor your heart rate, your respiratory rate,
Sure.
and say people for example, COVID, right?
Right.
Nobody can see COVID. Nobody knows that they're going to get it. You've got these asymptomatic spreaders. It's going to be the third highest killer in the US.
Yeah.
And if you have a biomedical device that you go home with, but you've got an app, instead of a doctor or a nurse calling you up 3 or 4 times a day, you've got a artificially intelligent app driving, not only sending your biorhythms and your digital vital signs, which is why I love their title, checking for vitals, um, is is important because when you can use those waveforms, and I see you've got that on your logo, to
Yes.
determine and predict what you've got for a patient, that is the secret sauce for predicting and keeping you better. Because I think we can stem this whole COVID surge in hospitals, which are, and we can do, guess what? I'm still going to be doing heart surgery despite COVID. Come 2, 3 years' time, people are still dying and getting sicker if I wait.
Right.
So I have to operate. And I thought to myself, well, not me. My wife thought to herself, well, why didn't I come up with this app? And let's do this and use video technology to look, which is similar to deep fake stuff. How can we predict somebody who's in atrial fibrillation and prevent people from having strokes? But at the same time, 20% of people who have COVID have an abnormal heart rhythm.
Yes.
And that is how you can pick up some people and heart rate variability and all her stuff that she's doing can be in this app, which allows you then to build an ecosystem with the home and the hospital to prevent people from coming in. So, similarly with heart disease. So, you get these patients then who come in who have been identified, and you can treat them and use the resources in the hospital appropriately.
Okay, so that is, I think, amazing. And I don't know if you're at a place where, because I everyone has like an Apple Watch or a Fitbit or sort of those activity trackers. And my Apple Watch will tell me if my heart is beating abnormally. Are we to a point where, your data lab is able to access those records? And that may
Yeah,
be completely non-HIPAA compliant. I honestly don't know the rules on that, but I could see how a huge data set like that, every Apple Watch user, you guys getting that data and then comparing it to how many of those people have gone in for a heart issue, you could, through machine learning or whatever process you use, that would be very beneficial in generating a profile of someone who is a month out from having a heart issue. Is that sort of how you've gone about it?
yes, actually, very close. So, we are looking at terabytes of data.
Yeah.
And if you can think of, say, NVIDIA, who've got these little chipsets, which basically GPUs sitting by your bedside, but actually is in your phone. And we're going to work with them to try to develop a model where every single device that we have in the hospital and now at home with other companies such as Nihon Kohden, then we can take those terabytes of data and it is, everybody says data is the new gold. Well, it really is.
Yeah.
Because I think, but it's also personalized. It has to be handled with very kid gloves because, people are buying medical data on the on the dark web and it's the highest commodity. And so it's very dangerous
Yeah.
to be handled in the wrong hands. It has to be institutionalized, I feel, because you have more regulations and more transparency. And I think that by doing all of that, yes, you are able to use terabytes of data to then predict for you with your Apple Watch that you're wearing now that because your HRV has gone down, and your demographics and all the clinical weights made on a decision matrix using AI, will be able to then predict for you, personalizing your therapy, that next week possibly you will be having an arrhythmia that could lead to sudden cardiac death.
Hmm.
And that's what happened when I met a young kid who I saved, who was an NHL hockey player called Craig Cunningham. And he didn't know he was going to die on the ice for 83 minutes. And then put him on ECMO. And we developed a new method to go through the heart to decompress his heart. Uh, and in 5 days, we took off the device, and his heart was back to normal again.
I'm sorry, did you say
Um,
he was dead on the ice for 83 minutes?
yeah,
So
his name
he
is Craig Cunningham.
so his heart was no longer working for a total of 83 minutes, and you had him on ECMO and you helped remodel his heart, and then you got it working again after just 5 days on ECMO?
Yeah, because of the new way that I placed it. I put it through the apex of the heart, and now that's being done. And we created the new cannula for that, and people are using it, and that's what I'm going to do in my ECMO program. And that's for because if you put there's a really cool ESPN and a TSN video on it, and it's called Life or Limb, and it's Craig Cunningham and me. It's our story, and it was 3 years ago in November the 19th. It will be the third year,
That's
and it's
amazing.
really cool. Yeah, you should have a look at it.
I definitely will,
It's
yeah.
um, it's a cool story about using technology on a kid whose heart that we saved. And um, so Craig, who's Canadian, and I love Canadians, and he, you know, it's a funny story, and you'll see it when you see the video. But he is a very humble kid, and this is now how we want to use technology to save millions. So look, I'm always going to operate because operating for me is like a hobby. I love it. I love coming in every day. I love where I'm working. I love what I'm doing. I love the team I'm with,
Sure.
and we have a lot of serious fun, if you like.
Sure.
But we just like you walking in and the job that you love, and
Yeah.
I think we make a difference to patients. But I think what's crippling for me is that how can we extend that to millions of patients? And technology is the way that we do that by preempting and using machine learning and artificial intelligence to try to make that happen, whether you're at home or in the hospital. And that's kind of, if you were to think, well, what's the thing that you would contribute to society, saying? It would be that. It would be using the technology to make the difference to millions of lives, not just one or two that I love doing and doing every day. And so this is where I think heart surgery has come to in a new paradigm, where you can be more astute, more creative, and use the new kind of pioneering with waveforms and digital vital signs in apps, as well as in hospitals, where you can use the technology to then gather terabytes of data to analyze, to augment. The machine's not making the decisions for you, you're guiding the machines.
Sure. Yeah.
And that's what people often mistake. And I think hopefully the unread soul would understand that by now.
Yeah, I think most people who aren't super knowledgeable about it think everything's going to become like Terminator and it's going to be Skynet and everything's going to go bad. It's not like that. It's very much human directed machine intelligence. At least right now. Skynet may happen years and years in the future, but for now, it's not
Yeah,
that.
it has to be directed with the right people, because if you have some archaic dinosaur making the decisions without harnessing the technology or using it, um, then you end up with the wrong outcomes. For example, IBM Watson failed because the right input, there wasn't the right input
Mhm.
into making IBM Watson ask the right questions, but also use the power of the technology to make the right decisions.
Right.
And so it failed and it flopped. And that's where I mean, IBM, I thought was going to be, very iconic in what it was creating, but it never did. And that's why other people came up with their own stories of using contextual artificial intelligence to then be more plastic in its thinking, to make better decisions for our patients, which I think we design and we generate and we should control.
Absolutely. So, with this data set that you're using, and you may be there now, but my question is, how far out is it that someone could download an app on their smartphone if they're at all concerned, maybe under doctor recommendation, or if they're at all concerned that they might have a heart issue, and the app just sort of passively monitors their Fitbit or their Apple Watch or whatever, and it alerts them. How far away are we from that sort of ubiquitous adoption of an app like that?
I think with the crisis that we're under, it's forcing us to catalyze this to be around the corner.
Yeah.
Um, and the technology exists. It's a matter of putting it in the right hands
Yes.
of the people who know what they're doing. And you like the thinking of Elon Musk because it's contrarian. I do like the thinking. I miss Steve Jobs to a
Yeah.
large degree, not because of his bad things, but because of his innovation. But also the beauty of what he brought to the world. And I don't like the small-mindedness of people who create obstacles in medicine. And I think that you don't need the FDA to a large degree. It regulates, but it's intrusive.
Hmm.
Just look at the CDC. The CDC's falling apart because they don't know what's happening every day or every other day. And that is, peppered with different politics, which I don't want to get into.
Sure. No,
But I
absolutely.
think that apps are around the corner. I think Apple are doing a good job, but I also think Google are doing a fabulous job
Hmm.
with lifting the barriers of uh, the technology, but also being responsible and accountable. Because people are innovative by nature.
Hmm.
They want to do better. They want to make things better for people, and these companies are actually driving that. But the brand is not them; it's us. It's how we are creating it. It's
Hmm.
how we are trying to change a patient's life. And so they provide the tools and the technology and the hardware and the software, but not the intelligence to driving the domain. And I think we're doing that. And I think it's a symbiotic relationship and cannot be parasitic. And unfortunately, the thing that colors the pot is greed, ego, and dollars. And
Yeah.
that's something that we have no control over. And, we just want to do better, like look after our patients. So I think I know we've talked a lot about a lot of things, but
Yeah.
I hope you've got the kind of gist of who I am and how we want to do things.
And for me, what is so fascinating about you and your story, although we do have a similar, I guess, genesis to what got us interested in what we're interested in now, what you've done is you've taken your love of technology and figured out a way to make what you learned in school, the cardiothoracic skill set, you've figured out a way to scale that. So you're not only impacting one person, you're impacting people. And that is beautiful. I think that's amazing. I did want to ask this just because you mentioned that, you were at a time at the Cleveland Clinic, and you mentioned, companies like Google, working on the kind of technology that you're working on at your data lab there. Do you have any contact with Toby Cosgrove, who used to be the CEO of Cleveland Clinic and is now at Google Healthcare?
So Toby Gosgrove operated on my mentor, Larry Cohn, initially, and then the current CEO, Tommy Mihalovic,
Hmm.
who's the reason why I stayed in this country because we were at the Brigham together, operated on Larry Cohn again, along with a good friend of mine, Ed Soltez. And so the answer in very short terms is no.
Ah,
Atul Gawande, who just left Amazon, I was his chief resident at the Brigham, and
okay.
everybody knows Atul.
Uh-huh.
But at the same time, you've got uh, 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 it, it makes no difference whether I know them or not. But at the same time, um, I think that what we are doing with the tools that we have is important because, as Toby Gosgrove said, patience and volume are power.
Yes.
And the same thing with data. And if it's used in the right way and um, harnessed in the right way, we'd be able to make better decisions for the individuals who are being cared for day to day.
Hmm.
And I think that's important. And I think how we bring together these forces with our, you know, miniaturized lives in comparison um, doesn't really m- make a dent in the waveform. I think what we're contributing is really the chemistry of what we can influence in the recipe, and that recipe is what we can design if we like.
Sure.
Um, I, I love what I'm doing. I think I'm in a very fortunate place, and I think that funding is a critical component, but that doesn't mean you can't be perseverant and creating something impossible out of nothing.
Sure. And I guess my reason for bringing up the Toby Cosgrove kind of Cleveland Clinic Google is I did sort of wonder if, and I normally close with a question asking, what do you tell people who look to you as a mentor and why you should get into whatever specialty you're in? I think a more appropriate question would be if you're already a doctor and you're already doing cardiothoracic surgery and you're looking to get into I hate to say a higher level, but incorporating sort of technology and finding funding to do studies like you're doing, how does one go about doing that? Is it all a matter of luck and just connections, or is there some legwork someone can do to sort of spin up an idea and create like a data lab like you have?
I've done it with no help.
Okay.
So it means that you have to be self sustaining.
Yeah.
Um, I think that if you were to create anything, it's sheer perseverance and sweat. And
Sure.
if it were somebody who is younger than me, and I tell a lot of people in my lab, you've got to know that I'm available. You've got
Hmm.
to know that I'm going to be working harder than you. And if you wanted to work harder than me and do better than me, and I will help you do better than me.
Yeah.
So I always want people to do better than what I've done. I think my, you know, uh, kids in the lab are always looking up to me, but at the same time, I look up to them too for trying to say, look, you've got an opportunity here to do better than I ever have,
Hmm.
and you should try to capitalize on every single opportunity that you've got to do better. And I think, yes, being not necessarily at the right place at the right time, you've got to earn it.
Yeah.
You've got to be. I don't believe in luck. I believe in being um, in good preparation and doing your homework. And Einstein wasn't a genius because he had the genes for it, despite what people say. He worked his ass off.
Yeah.
And I think that you have to have and educate yourself to have the tools necessary to create the flavor you want to show people in life. And I think that that will only come if you want to be good at something. You've got to be deeply focused. You've got to be perseverant. And you've got to be stoic to some degree and mindful of what the past is, but also be progressive enough to be aggressive for what you want.
Yeah. You sort of have to be willing to put in that sweat equity to not only have the idea, but to see it to fruition.
Yes, and beyond.
Yeah.
If you can't see it through and determine the outcomes and also learn from the bad outcomes and your mistakes, you will never be anybody.
Right.
And that's important. I do that every day in my OR. You have a timeout, which is not your traditional timeout. It's a story
Yeah.
about the patient, but then at the end of it, you ask everybody in the room, "How could you have done better?" And even if the case went really, really well, there's always something you can improve on. And
Yeah.
it's those, why did the British Olympic team in cycling become the British Olympic team? Was because it was those little increments, that 1% improvement.
Hmm.
That's what it was all about. And that's what I do in my OR every day. And I think that uh, uh, it's very easy to have that philosophy if you know that there are people out there who are better than you, but it's do it for yourself and the respect of the patient. The patient's always first.
Well, they have to be in this line of work. They have to be. And one thing that, not to close with a quote from my father, but one thing that he drilled into us as we were kids, and I'm sure he's not the first or only person to say this, was that failure is not what you've done if you did not succeed. What you did is you learned something and now you move on. And I feel like that is sort of what you guys do every day in that data lab. You're figuring out ways to make it work. And you probably learned 1,000 ways that it doesn't work, and you're going to figure out the ways that it does work. And that's what's so interesting to me about what you're doing is that you're taking just this huge amount of data that means a bunch of different stuff. It doesn't necessarily all have to do with the heart, but you're taking all of this data and then you're extrapolating what is important, finding its sort of importance and weighting it with a value, and then finding a way to make that super predictive of future outcomes, which to me is fascinating.
Yeah, no, I think you've got it. You've got it in a nutshell. I think that was a beautiful summary. I hope that we are able to contribute in a meaningful way to people's lives, and I think that I'm very fortunate to work with the people I do have with me, and including big corporations. So
Yeah.
I think the most important person who's fueled my insight and my I'd say maturity is my wife, and that's how she's led her life and her philosophy, and she's made a lot of sacrifices too along the way with our 4 kids, but she's driven a lot of innovation that she wanted to do, and she's a good team player, and she really makes me probably the only person who now makes me think how I can do better.
Well, Zain, I really appreciate you taking the time today to talk to us here on Checking the Vitals. I'm infinitely fascinated in what you guys are doing there, and I'd love to know more. So we may have to do this again in the future.
That'll be a pleasure. It was lovely, and thank you for asking meaningful questions. And it shows that you love what you're doing, and it really makes it empowering to the person you're interviewing because it brings the best out of them. So that was really meaningful to me too.
Well, thank you.